Okay, what did you notice yesterday? Your Skittles. When you were adding your Skittles, did it look like this?
Oh, yeah.
Oh. And then when you are taking Skittles away, did it look like this? You don't like it? Okay, I'm waiting it for it to be quiet. Okay, so when we had linear functions, okay, linear functions had a constant rate of change, right? Is that happening here? There's change, but it is most definitely not constant. I had notes already for this, and I cannot find where they are. Where I said. Okay, so let's talk about a linear function looks like this. Okay, where we had a constant rate of change. We had rise over run, right? We had a slope. Okay. Did you notice any patterns besides the graph? Did you notice any patterns in that Skittles activity? It felt a little random, okay? And it was probably hard to see because the numbers probably weren't like super awesome. But what happens in an exponential function is that our y is going to be multiplied by a constant factor. Okay, so in our linear equations, we added the same number from one coordinate to the next. In an exponential, we are going to multiply the same number from one to the next. Okay. So we are multiplying by the same number over and over and over. Okay. So you need to be able to do two things. You need to be able to recognize that we have an exponential function, and you need to be able to evaluate an exponential function. So let's first of all, let's talk about a linear function is going to be y equals mx plus b. Okay. Where an exponential function, our x is going to be in the exponent. Exponential. Exponent.
Oh, I get it. I get it.
We're going to use a because m we usually reserve for slope, and there's no slope in this case. Okay. So on the next page, let's look at this number one right here. Okay, do you notice how we go up one, up one, up one? Okay, well, that's good. But it's the y's that we really care about. What's happening from one y to the next? So I can multiply by 1/2, multiply by 1/2, multiply by 1/2. Multiplying by 1/2 is the same thing as dividing by 2. I'm trying to make a point. An exponential function means our consecutive y values are being multiplied by the same number. So this is an exponential function. As long as the x's are consistent, then the y should be consistent, okay? If the x's aren't consistent, then we're gonna have a little bit of a problem. What about here in number 2? How, what's the pattern with our y's, Abby?
Because they add 4 every time.
Okay, so we are adding 4 every time. And if we are adding the same number to consecutive y's, that means we have a linear function. Okay. You and your elbow partner, please determine whether 3 and 4 are linear or exponential.
Wait.
Yeah.
What makes it different though? Is it because
I know.
we're
It's just trying
adding instead of
Y,
multiplying? Or
Yes, that's exactly it. That's exactly it.
I know.
So are we adding the same number over and over or multiplying the same number to get from one to the next? Like over here, we added 4, added 4, added 4. Here we multiplied a half, multiplied. So 12 to 9, 9 to 6, 6 to 3. Wouldn't we be like subtracting 3 every time? So that would mean we have a linear function. If we were,
I don't know.
Yep.
Would it also work if like you were adding a negative number?
Yes,
or-
yes. All right, so number 3. I don't remember the name, but maybe not. It's making me a little bit. Okay. Number 3. Preston, what do you think? Linear or exponential? It is linear. Estelle, why is he saying linear? Okay, we're subtracting 3 over and over. Subtracting 3, adding -3, whatever you want to say. If we're adding or subtracting the same number over and over, we have a linear function. Okay, what's number 4? It is exponential. Okay, we multiply by 4 over and over to get our exponential. Good. Estelle.
It's like multiplication or division is exponential and subtraction or addition.
Yep. So let's talk about how we evaluate a function. Okay. Here in number 5, y equals 3 to the x. If x is 5, I'm going to put 5 in for x. And now I have 3 to the 5th. Nirvan? Great. Thank you. Okay. Okay, how about this one? We have 1/4 raised to the 3rd power. 1/4 to the x, but they're saying x is 3. So if I have 1/4 to the 3rd power, well, what's 1 to the 3rd power? 1. What's 4 to the 3rd power? What if x was -2?
1.
I know. So if y equals 1/4 to the -2, okay, so then we would have to do this. We would have 1 to the -2 and 4 to the negative 2. But what do we do with exponents with that are negative?
We put them down.
Okay, and if they're in the denominator, we move them up. So yes, you are right. This would be 16. Janet. Yep. If you have a negative exponent in the denominator, then it gets moved up. Once it crosses the fraction bar, changes. Okay. All right. I'm gonna have you move to the table right here.